Hello, welcome to this session on some of the important topics on networking. VLAN, which is virtual LAN, then virtual private network, which is implemented using IP tunneling. Then let us see the difference between what is wide area network and internet. Of course, internet is a wide area network itself. Then how do we have private IP addresses inside our organization and still we are able to communicate with the external world using public IPs, and network address translation, which is a backbone of this implementation. Then we'll wind up with mobile IPs and voice over IP. Now let us look at what is virtual LAN. This is a virtual local area network, which in turn means that it's at the L2 level. So we have to remember that it's at L2 level, layer 2. That means we are doing something with the frames, Ethernet frames, if we are using Ethernet. Now let us look at a typical implementation in an organization where you have a switch, one physical switch. Maybe it may have 48 ports or 28 ports, 24 ports. But we want to implement multiple logical LANs. We have one physical switch, but we want to implement multiple logical LANs. What I mean by multiple logical LAN? You know that LAN means it's all connected hosts which can talk to each other. That means they are on a L2 layer, wherein the Ethernet frames that they are sending it as a broadcast frame, suppose destination Ethernet address is all ones, okay, 48 bits or 48 ones. Then that Ethernet frame will be received by all the hosts in the LAN. Then we say that it's one broadcast medium. That means if one of the devices decides to broadcast Ethernet frame, every machine in that particular LAN would receive it. Now earlier, so far, what we have seen with a one switch, a 48 port or a 24 port switch, we saw that all the hosts are on a single broadcast medium. That means every host is connected to a single physical LAN, wherein if they decide to send one broadcast frame, it will be received by all of them. Now we don't want that kind of a mechanism where multiple hosts are receiving the broadcast from one machine, or in other term, we are able to receive the frames which are being exchanged between two machines on a particular physical LAN. Now if you want to divide a physical LAN into a logical LANs wherein they behave as if they are on a different logical network. So if we need to do that, we need to do something at the L2 level. On Ethernet frame, we need to have something apart from the destination destination MAC address and the source MAC address, destination MAC and source MAC. We want to have one more ID called VLAN ID. Now this is another segregation to indicate that this frame belongs to a particular virtual LAN within a physical LAN or a switch. Now we are not going into the details of how this VLAN is implanted into that frame. Remember that there is one byte of field which is reserved for a VLAN ID that segregates different virtual LANs within a physical LAN. Now assume that we have 4 VLANs. You can see the different color. So these blue are all in HR and the green machines are on another LAN. Like sales is also in different LAN. So we have 4 different VLANs in a physical single VLAN. That means if whatever the frame being sent by this guy will be received only by this, it won't be even seen by these machines which are in the same physical switch. That means switch is not going to send it to everybody, even if it is a broadcast frame. it is going to segregate based on the VLAN ID which is embedded within the frame. So each of these machines, when it is communicating over the Ethernet, is going to add this information on the Ethernet frame header, so that the switch will be intelligent enough to only send packets, or sorry, frames, to a particular machines which are in the same VLAN. So that is the beauty of having VLANs. So a VLAN is nothing but a way of creating multiple virtual switches inside of one physical switch. So it behaves like a multiple multiple switches, though it is a one single physical switch. So how many physical networks are here? Actually, physical network is one, but because we are creating multiple VLAN with different IDs, we have 4 VLANs inside them. But remember, we also saw that if you do not have any VLAN created, then the VLAN ID 1, which is a default VLAN, which comprises of entire switch. So if you have created 4 VLANs and then still you have some ports which are free, then they belong to VLAN 1. Okay. So apart from this 4 VLAN, there is one default VLAN could be there, based on whether you have switches which are not part of a port, which are not part of any of these 4 VLANs which you have configured. Now how do you configure it? You go into the switch and then say individual ports or switches interfaces belong to which VLAN it, and we mentioned that VLAN ID in them. Okay, that's how we configure it within a switch. As far as the hosts are concerned, they do not have any configuration associated with the VLAN, though you know that a HR machine connected to this port, parts of HR VLAN, but we don't configure it anything on the host side. It's only on the switch side. So the need is to have exclusive access to the LAN belonging to various departments within an organization. The packets belonging to finance should be accessible only to machines connected to finance VLAN. So we don't want other machines to know about it or even receive it. HR VLAN, HR LAN, or we call it as a VLAN, which only HR machines are connected to, they only exchange information and they only see, and it won't be seen by other divisions within an organization, though they are all connected to the same physical switch. So basically, VLAN is a logically separate IP subnet which allows multiple IP subnets to exist on the same switch or a physical network. Okay. So VLAN is a logical broadcast domain. So each VLAN is a one broadcast domain. That means if any Ethernet frame with the destination MAC address as all ones, FFFs, it will be only received by the machines which are part of that particular VLAN. The Ethernet switch is configured, so you have to configure the Ethernet switch that which are the ports are part of which VLAN, then the host connected to them become part of that VLAN. Each group of ports or interfaces are associated with a particular VLAN ID which you configure it on a switch. The frames belonging to the VLAN ID are sent only to those ports which are part of that VLAN. So remember, Ethernet frame is tampered with and we associate a particular VLAN on that particular Ethernet frame. So as the host sends a frame, the switch adds that VLAN ID, and then because it knows that physically this port or an interface is part of that VLAN, and when it is exchanging across the switch which is physically there inside the different ports, the exchange of those frames are happening only within that particular VLAN. So what is the intent of them? Interconnect of they are for security purposes, and then if in case if you want the host connected to a particular different VLANs want to exchange between them some IP packet, it can't be done at the switch level because it is going to treat them as separate broadcast domain and they are not going to allow the packets to be exchanged across the VLAN. So we need a help of a router. So this is called a router on a stick configuration, wherein we will be creating multiple sub interfaces and each belonging to different VLANs. So and then we also associate a particular IP addresses on those sub interfaces which are part of different VLANs, so that the packets or the frames reach there and the Ethernet frames is opened up by the router and it is going to look at the IP address, and based on that it is going to send it across a different VLAN. So you need a LAN a router to make sure that multiple VLANs talk to each other. Maybe we will have one lab interface which explains about this. Even though a VLAN are part of the same physical network, the frames exchanged over one VLAN is not visible, as I told you, or accessible to the machines on other VLAN. So we need to have a router which sends that particular frame if it is destined for another VLAN. So even if you keep a one Wireshark on this interface, you will only see the packets which are belonging to this particular VLAN. So this is all about VLAN, and the advantages are security because the machines are separated out, so they only exchange information among them, and because the broadcast mediums are split across multiple logical VLAN, you don't see unnecessary traffic which is happening among engineering department may not be visible to the finance department. So the performance is better and the bandwidth within the VLAN is preserved. Now let us go into another area, which is virtual private network, wherein we have a different motivation here. We have one logical LAN, okay, is exactly opposite of what we saw in VLAN. In VLAN we saw that one physical network, physical LAN is there, and they are separated into logical LAN, okay, logical LAN. It is called VLAN. Now what we want is, we have different physical network, okay, interconnected, okay, they are all different physical LANs. That means I have different switches and they are all connected, and I have machines connected to different ports of those or interfaces of those physical switches. Now what I want is, I want machines belonging to different physical LAN belonging part of one logical LAN. So I am trying to construct a logical LAN which is spread across different physical LAN. That means what? If a machine here and another machine here wants to exchange a broadcast, suppose this is sending a Ethernet broadcast, it will be sent and received by these two machines, also about these two machines. That means what? This packet is going, this frame is going, and then it is sent to others. So though they are spread across different physical LAN, they are treated as one logical LAN and one broadcast medium. Okay, this blue is all one logical LAN. That means any broadcast happening, it is happening there. Now you may wonder what is the need for it. We will come to that now in this. Now suppose I have a single organization, but I have branches all over the country. Different cities are there. I have a Bangalore branch, I have a Hyderabad, wherein my corporate hub is there, or I would say that this is my head office, headquarters in Hyderabad. I have an office in Bangalore. Now a machine here, suppose I have a HR team here, okay, and then I have a HR team here also. Of course there is HR head will be sitting here in the headquarters, but they need to be in a single VLAN, HR VLAN, correct, but they are physically separated out. Now how do I make them come together? That's how the VPN is trying to help us in doing it. So what we do here is, we have a one network here, one switch here. Of course if I am connected to internet, there will be a router, okay, one VPN router, okay, I call it as a VPN router. And then I have another network in this corporate office which is connected to internet. I have another VPN router. Now always remember, if I have to connect to internet, we need a gateway. Gateway is nothing but a router, okay. I have a router. Now what I want to do is, I want to bring this particular network which I have in some office in Bangalore, and some other network which I have it within my office in Hyderabad. I want them to be as if they are together in one physical location, though they are separated in terms of distance, thousands of kilometers. Now how do I do it? It could be in different continent also. I may have a headquarters in San Jose, and I may have one branch office in Bangalore. So how is it implemented? Using internet. Of course, I want to communicate among them, between them. I need a help of internet which connects these two. But I want to make sure that it is as if they are together in a physical network. That means nobody is having access to whatever I am exchanging here among the machines, and among the machines nobody has an access to that. Then what should I do? What I do, I want to make sure whatever the IP packets, because IP is the final routing entity, right, or a datagram. IP packet, that's what is getting routed. So I need to protect it at the IP level, and then different applications are there running either TCP or over TCP or UDP. Different applications are running in my machine. Now once it comes as an IP frame from my one of these machines, one IP frame is generated. I want this to be sent without anybody looking at it, and it should land in my other office. Then I will open it up and send it across. Then it is safer. But why do I say that it is not safe when I am sending it over internet? Because internet is over public network. There are different routers provided by different service providers, and they can be compromised, and they can also look at the IP packet which are going over their routers. If a router is receiving an IP packet and opening it up for routing purpose, it can also look at the content of datagram, right? I have an IP packet. I am opening the router is opening the IP packet. It is a header here. IP header is here, and IP data is here. Now, if it is able to see this content of the IP packet, it can also see the content of data, right? So I want that to be protected. So how do I do it? Unless I encrypt it, I cannot do it. But the problem is, though I can encrypt this, whatever is the data portion, still I don't want to reveal the IP addresses that I am internally using. Okay, even I want to protect my IP addresses within my corporate office, because IP header itself has a lot of information about what type of traffic is going, and how many, whether it is getting segmented or not. So there are a lot of information which is revealed in the IP header itself. So I want to protect even that. So if I want to do that, what I do, I pack this IP packet itself, my entire IP packet, okay, including the header. I put it within another IP header. Okay, let me say this is a private IP which is inside. This is a datagram. Entire IP packet itself, I parcel it within another IP header. Okay, that means this IP header is visible outside. Maybe I will call it as public IP. This is, maybe I will call it as a private IP, which I will come to that later. So this itself, the entire IP packet is put inside the another IP packet. That means I am calling this entire thing as a datagram. And then while I am putting it, I don't want to put it as it is. I want to encrypt it. Okay, I will encrypt it also. That means I will modify every bit of information within that. Even my IP header in content are modified. Even the checksum inside that is modified. It's okay. I am going to encrypt it and put it inside. And I am going to add another header which is visible outside. Anybody can use it to route it to my destination, which is my entry point into my network, which is, that's why it's called a VPN router. Two routers are there. I have one IP address here, which is public IP address 1. I will call this IP public address 2. I put this inside here, source IP address as IP public 1. Okay, this is the source IP address, and destination IP address I will put it inside this as public address 2. So as far as the internet is concerned, it is coming from this router and going to this router. That's all. It is not directly connected. Remember, there can be multiple routers inside, the internet, but I am delivering it from here directly to this. It's like a, suppose I can give you one scenario wherein your friend is flying to US and you don't want to send a packet to your another friend who is living in the US, maybe not in the same city where your friend is going to. You are asking your friend, please take this packet. Of course, you don't put any unwanted stuff which will put the person who is carrying in the airline in trouble. Of course, a valid gift that you are putting inside the packet, or which you are giving it as a carry-on packet to the friend, and he carries it in his as a check-in luggage. He lands in the US. He is going to live there, maybe stay there for a month. So he will open it up, and then you have put your friend's address, which is a US address, and then he gives it to a courier for there, because sending inside a US is much cheaper than sending across the country. So what is happening here? You are actually using somebody else to carry it to the destination where you want it, and then later on it is going to be not sent directly. It is not reached the destination yet, but your friend is going to use the courier service there within the country to send that packet across. Similar thing is happening here. The VPN router here is receiving it and then opening the actual IP packet. Now your network is here, and it may be connected not directly, but still it will land into that network. Okay, so you can open it up and then send it across. So this is how a VPN works. So that means you can encrypt it also. You can even make sure that your friend doesn't tamper with your packet. So it is maybe some secret letter or something what you are sending. It will be received by the receiver. So requirement is to have multiple physical network at different physical locations to be part of a single LAN. To interconnect multiple physical LANs of a big corporate or a company which is spread over multiple buildings and cities into a single logical LAN over internet. So the exchange of data between physical LANs over internet need to be protected. So you do encrypt it and then send it across. So this is what is called IP tunneling. So what you do is you have a final destination IP address is this, and your source IP address is given as per your local host address. Okay. Now what you do when you are sending it across the internet, you parcel this whole thing as a IP, as a datagram inside, as a payload inside a IP packet, and you formulate a new header here. Now this destination IP address is same as your VPN router. Okay, and then your source IP address is nothing but this router's source IP address. Okay, so now what is happening is IP packet inside another IP packet. That's all. That means the payload, original payload that you are having is becoming, along with its own IP header, becomes a new payload for this particular IP packet. Okay, that's how you do it, and then you also encrypt it. And remember that on the receiving side, you should decrypt it before sending it across the network. Otherwise, whatever the value is there will not be make sense for the destination network. So it has to be decrypted, and the keys may be available with the two routers, because it is your own organization. So they will be able to exchange the keys, and they can get the key for encrypting it and then sending it across. So in that way, whoever comes across this packet on the way will not be able to make any sense out of whatever is carried by your IP packet. So this is a very safer way of delivering your private IP packet over a public infrastructure to the target IP destination. So the virtual link is created, and before that you need to make sure that the link is created. Okay, that I am going to be sending IP packet inside the another IP packet. That should be known to the target router. Whenever the router at the entrance of the tunnel wants to send a packet over the virtual link, it encapsulates the packet inside an IP datagram. So the destination address in the IP header is the address of the router at the other far end, while the source address is that of the encapsulating router. So this its own source address will be there. Because why should it know? When it is getting a reply back, it will be sent to this. Again, it will pack it and then send it across, and it will again decrypt it and send it across the target. So always remember, it's not the one-way route or traffic. It will be a reply will be coming, and that also will be following the same philosophy that the sender have followed. So the original IP packet is kept inside another IP packet. So supplement, you can also supplement it with the encryption. So tunnels are provided a mechanism by which you can force a packet to be delivered to a particular place even if it is original header, okay, was different. Okay, the one that gets encapsulated inside the tunnel header might suggest that it is should go somewhere else. So what you do is you are keeping another IP packet inside the header, okay, another AP. So we will see an application of this in a mobile host in a short while from here. Tunneling is a powerful and quite general technique for building virtual links across inter networks. Okay, so tunneling does have its downside. What is the downside? Because you are increasing the IP packet length. So because of that, it might get into some segmentation down the line, which has a side effects or drawbacks. Because when you segment a packet, it is going to get delayed, and it's going to be again segment reassembly has to happen on the receiving end. So that's it about VPN, and I'll quickly cover what is WLAN or a WAN, which is a wide area network. So it's actually a physically in a broader area. If it is network is there, spread across a particular organization, like a big campus inside or a university or a WAN or a IITs or BITS Pilani. So you have a bigger, larger physical or corporate or a institute, then there are physical switches around, routers around, and then they are connected through a WAN, which is called virtual wide area network. Now, if a WAN is managed by a single organization, that's called a WAN. Okay, we don't call it as an internet, though it's physically over few acres of land. We don't call it as an internet because they are all managed by one single organization. All the routers are managed by one single organization. When you call a WAN as an internet, when it is organized by or managed by multiple services, internet service providers, and maybe you have a cable which is undersea cable managed by some different service providers. So different routers in an internet are managed by different organization. We call them as an internet. So it's also a WAN. Okay, a largest WAN is the internet, which is managed by multiple different organizations. That's it. Now, what is the need for private and public address? Now, when you have an organization, within an organization, whatever the host you have, the IP addresses that we normally use, they all actually private IP addresses. The reason being, if you want to give unique IP addresses of IPv4 to every machine in the internet, this current IPv4 will not be able to support. So what is done is, normally we allocate the private IP addresses which is visible only within the local LANs, and they have a separate, though always the concept is the same, that each host in the LAN or network need to have a unique IP address which is still supported. Okay, so they are accessible and they are having different IP addresses, but they are all within the one private IP address. Now, when I know Internet Assigned Numbers Authority or Internet Corporation for Assigned Names and Numbers, they allocate IP addresses. They have already reserved some addresses which are private IP addresses. That's why you normally see when you log into a corporate or a industry or a institute, the IP addresses either belong based on whether they are class B or A address or C address. They will normally be starting with this. Okay. Now remember, this actually 192 or 168 is what is reserved. So that means the entire range of these addresses are class C. Okay, so within the your network you may have a /24, but at the IPv4 address level, entire 192.168 is given for private IP addresses. So you cannot use as a public IP address 192.168.100. something, you cannot use it as a public IP address. That's what I'm trying to say, that 255 means that the first 2 bytes are only separating information that it is a private IP address, though we use it as a class C address most probably inside our organization. So these private IP addresses are used internally by many organizations. I can have in RVU 172.16, and we can also have the same 172.16 within IIT Bombay, but they can exchange information among themselves. Okay, and a person sitting on a RVU company host machine can send a mail to somebody who is also using 172.16 as an address within IIT Bombay. They can converse with each other. How is it possible? That means internally they have 172.16, but when they come out of their own network and they go over the public IP over internet, they have different IP addresses. That's why they are able to be sent over the internet and finally reaching the target IP address. So basically, without private IP addressing, we would have run out of IPv4 address. So there are not sufficient enough addresses. So we are using internally different IP addresses, though they are common across different organizations. They are visible only within them. So when they come out, there are different IP addresses are used. I will explain it shortly now. So it is like you have your own pet name within an family, and when you come out the organization, you have a common name which is uniquely identified by anybody. So there may be different people having the same pet name like us within their own families, but when they come out to public, they exchange their own addresses, their own names, which are unique and known to everyone. Okay, but you cannot put your pet name in your passport. Okay, then there will be Chittus and Mittus. There are many in the within home. You cannot put that as a in your passport. Then there will be a lot of confusion in the world. So the large airport. Now, what is the use of even private IP addresses? Suppose you have seen a lot of display boards in an airport. So if you look at the IP addresses used by those airport displays, they may all be same. One airport here and some other airport in some other part of the country, they may have the same IP address, but most probably the displays which are there, they are all connected through Ethernet or a Wi-Fi, but they are all exchanging information about the departure and arrival of flights within the airport. So they don't even have a need to communicate with the outside world. So another reason that you don't expose your private IP address to the outside world is security, because you don't want to expose your own IP addresses. So similar thing what I told you about VPN is what is done here, similar to that. Okay, where your internal IP addresses are not used outside your network. Okay, now how is it implemented? This is using a NAT, network address translation. What you do is you translate your private IP address. When you send it across, you send a different IP address which is publicly known. Okay, so imagine your RVU or other any institute is connected to internet. That means they are using the ISP. ISP would have provided some public IP addresses. They would have given couple of IP addresses which is released to the RVU, and you have thousands of private IP addresses within the organization. So you have only limited public IP address, but still you need to make sure that every machine on your internet on your subnet inside your network is able to communicate with the outside world. That means suppose if I am pinging one machine and it goes out and then comes back to me as a reply, that means I should get back the reply delivered to me. It's now somebody pinging from here should also be able to get it back to his own machine. If that has to happen, there should be some mechanism of what packet is going out from which machine, and then when the reply comes, I should be able to map it to the same machine. So the NAT performs that job. Now NAT is a way of implementing it. Okay, network address translation, and it is done by normally a router which is a gateway to the external world. So let me take an example. Suppose I am having a local IP address this, okay, and it is a TCP IP packet or a UDP packet which is having its own port ID. Now what I do when I am sending it out, I am going to replace my source IP address as this. Okay, that means this is very limited number of IP addresses. That means many packets coming from my own local machines will be getting this replaced with this particular source IP address. Destination IP I cannot change because this machine wants to ping on machine somewhere in the internet. That destination IP will remains the same. I am not changing the destination IP address at all. I am only changing the source IP address from my original address what I had to something which is, see here, I am using for 11 also I am using 39, but for 12 also I am using 39. That means two private IP addresses get the same source IP address as same. So I should have some other unique way of identifying it. That's why I am using this particular port ID, which I am replacing it from here to something locally here. So I have to have a mapping. So when I am sending it to the original machine, I will replace it with both TCP port number as well as the source IP address. I will change it. But when it is going on the internet, I will change the IP address as this, source IP address as this, and the port address as unique. Okay. So when the reply comes back, I will get the reply to this port address and to this public IP address. So I have a mechanism of differentiating between the traffic which was originated from either 11 or 12 or 10. I will have a different IP address. So here 5000 I am using, no problem, because I am using different IP addresses, so no issue. So that combination of this public IP address that I am sending it across and the port ID that I am going to use should be unique. This should be done in one machine. Why I am very particular about it? Because remember, this 11 and 12 and 10 are all running on different hosts, and the source they have a port IDs which are generated by their own applications. There may be common port IDs. So what I am generating on this machine, I cannot make sure that it is different from some other port ID generated by some other machine. So port IDs are a part of TCP communication, which is unique across different socket connections that are happening. So I don't have a control on the port ID that I am using on one machine and another different machine. That's why I come to a common machine, which is the machine which is a router, a NAT router, which makes sure that I use unique port IDs for a unique combination of IP, public IP and the port ID. So I always get a combination of these two which is unique. So when I send it out, it is unique, and when I receive it also, the destination machine is thinking that it is communicating with this public IP address, but actually who is communicating is this machine. Okay, so you are protecting who is actually communicating with the destination machine. You are protecting it. Okay, it is secure. Okay, so that's how the NAT functions. That way what you do is you make use of only limited public IP addresses and catering for different private IP addresses and providing the capability to communicate with the external world with a limited public IP addresses you have. So that way IPv4 addresses are not used by every host in the machine, in the network. It's only few of them is being used. So ISP of a particular organization doesn't give that many number of IP addresses which are needed by the hosts which are there in the network. No need. You can only give handful of IP addresses, public IP addresses, which can be shared by different hosts within the private IP, within the private network, because you are using different port numbers which are unique and which are freely available, enables this kind of mechanism. So only problem here is that you need to transfer every IP packet and translate. Here you are not packing this IP address, it's within that. It's similar, it's not same as VPN wherein you pack one IP address within another IP packet. You are actually manipulating, changing the source IP address which originated from this machine as if it is originating from this IP address. And you are also tampering with the TCP packet, TCP header, which is part of wherein the port ID is there. Okay, so it is because it is within your organization, you are free to use it, and you need to make sure that you replace it back when you are sending the reply back to the machine. So that needs to be taken care of by the NAT. So this is how network address destination happens, and which protects many machines which are in the private network to communicate with the external world with one single IP. So a public IP address. It could be single or many, but limited number of public IP addresses. I hope this is clear to you. Now, mobile IP is a quick summary wherein you have machines which are moving across. No mobility means user moves within only a particular wireless network. Okay, you have a wireless router within a classroom. You are within the classroom. Yes, you can do it. That's called, not called mobility. When you move out of the LAN, is called this mobility. So when you move from, suppose you have a BTS, one wireless Airtel maybe, okay, and then you move across, maybe you are going from Bangalore to Mysore, then you will be going across different BTSs on the way, on the highway. So your call is getting transferred between the different BTSs, and then reaching the destination. So you may have one call, you have you maybe you are getting into a voice call or a video conference for, or you are watching one workshop which is happening for 2 hours, a class, but you are traveling between Bangalore to Mysore on the way, but you are always connected to the YouTube feed that is coming to you. Then what is requirement here is that your source IP address allotted to you is not changing on the way. So that means the traffic is coming always to the same IP address that you have been given during, from the beginning of your starting of your network to the end of your network, reaching the other network. So let me explain here. Suppose you are moving out from home network on a wide area network, which is maybe an internet, okay, to another network. You may be going from BLR to Bangalore to Mysore, but you are on a mobile, and imagine that you don't want this home IP address to be changed. Now how is it possible still you get connected to this, though you are traveling over a different network? So the VPN that I told you actually comes into the IP tunneling that I mentioned, is actually going to be used here. Okay, let me explain here. Now suppose you have your source IP address is this, okay, and you are sorry, that's a home network, and your source IP address is this, okay. Now you are, when you are on this network, okay, you are moved actually, suddenly you are moved, suppose, imagine, what happens is, any IP packet to reach here, the source IP, the destination IP of the packet should be belonging to this address, right? Now this address is something, this is the permanent address what you have here, okay, this is a permanent address is there, your machine is here and you are here, your permanent address is same, but your destination network is this. So any IP packet to reach you, it should be given this IP address, okay. So let me clear it. Now this is the IP address of your target visited network, you are currently here, and this is the address which is to be given to the IP packet, IP header, to reach this packet, to reach this particular network. But you are actually having originally the permanent IP address is this. So what I do, your IP permanent IP address, permanent IP address, I put it inside and another IP packet which is similar to what I told you in VPN. Here you may not even do a encryption, okay. It is only, maybe you are okay to know that packet to be seen by someone. Then your only way is, I do not want my permanent IP address to be changed. So what I do, I still think that I am connected to this network, okay, my mobile, okay, here I am showing it as a laptop. Imagine that you are connected to your own mobile hotspot, and then your laptop is connected, and you are in a car and moving. So that means your hotspot, your IP address, whatever was assigned to your mobile, remains same, okay. That IP address is this. Then what happens is, there is a home agent, a router in your home network is taking care of communicating to you. It keeps track of where you are, okay, and then this is the YouTube, okay, thinking that it is connected to you to a permanent IP address. So always it sends a packet to the home agent, which is in your own home network, and it knows where you are currently now. So suppose you are currently visited this, then it will put the packet, whatever it receives, it knows that it has to be sent to you, and it knows your current IP address, so it puts it, your packet, inside the another IP packet, and then creates IP tunnel and sends it to you, okay. So IP tunneling is done and delivers it to you, and this foreign agent knows that, okay, I am receiving which is meant for you, and it opens up and gives to you. So this is a different IP address than what is currently you are in. And once it opens up and then sends it to a switch, IP address doesn't matter, right? It's Ethernet frame, so it is delivered by this directly to you. Okay, so it should be on the same LAN. Okay, so you should not use this IP address inside this, because you are in a foreign world. You cannot use English inside Chinese, deep inside a Chinese village. You have to use Chinese language, so you cannot use the IP address which is different from what it is. So what is done is this router opens it up and then sends it as a frame, Ethernet frame, because it should be connected to the switch directly, and delivers it. So it is a direct delivery of that packet. So to summarize this, what is happening is, always this correspondent thinks that you are here and sends a packet to you with the IP address which is addressed to you, and that IP packet is put inside another IP frame which is IP tunneling, and this destination IP is belonging to the place where you are currently now. The foreign agent is, sorry, not to you, it is directly to the foreign agent here. Now imagine, for after some time you move to some other visiting agent, and you have a foreign agent here, another foreign agent 2. This is foreign agent 1. It will have some other address. Now what is done is, this address is known to this home agent, so it will put that inside the IP packet. Your IP packet is inside IP, and this address is put here and delivered to this directly, and then it will give it to you. Okay, this is how you are moving from one agent to the other agent. The mobile IP is done. Actually, your mobile IP is nothing but the IP address given to your device which is mobile, which is moving. When I say mobile IP, doesn't mean that it is a handset. It could be a laptop which is moving. Okay, so that's the mobile IP. So you will normally give one permanent address to it, and then there is a foreign agent and home agent. Home agent is aware of the foreign agent, and it puts a IP tunnel, creates a IP tunnel, directly delivers it to you, and then foreign agent opens the IP packet and delivers directly to the visiting device there. So before we wind up, VoIP is nothing but voice over IP, wherein you have a WhatsApp call or a Skype call, wherein whatever calls you have audio, when you speak, is the analog signal is converted into IP packet, digital packet. It's sampled and sent as IP packet, and then delivered over data over IP network. That's all. So voice is sent over IP network as a data. Okay, so what is being carried as a payload is a converted speech of your audio signal in a digital, compressed form and encoded form. Okay, there are lots of voice encoders, and that voice is packetized and delivered to you, and then it is converted and played back as an audio when it is received. So it is actually, your voice is sent over IP packet, IP network. So suppose, imagine you are calling from a landline, a mobile. What is happening is, landline is receiving your audio packets, and it is getting delivered to the exchange of your Banaswadi or wherever you are, to the BSNL line, and then because it is connected to the mobile, it knows that mobile is over a GSM line or maybe CDMA or whatever data connection, and you are receiving it on a mobile. So it is to be delivered to a IP network. So the gateway, which is at the BSNL exchange, converts your audio voice into a packet and then delivers it as a IP packet over the mobile network, and then it is delivered to your mobile handset, and which is playing back your audio, which is encrypted. May not be encrypted, it may be encoded. So it decodes that packet, voice packet, and then plays it back into your mobile. So when you speak back, that is also being sent over the network. So the TCP connection which is being exchanged connected between these two machines, or your mobile to two mobile phone, or between two laptops, or you are making a voice call, it's a data packet, and it is being sent over the IP packet. Okay, this is how normally a voice call is made over internet. This is called voice over IP. So this brings to the end of this discussion. These are all very important concepts which you are supposed to know as a network engineers. Bye bye.